let us take up some problems of equilibrium of spherical bodies like wheel or cylinders. So the question is, determine the horizontal force P necessary to push 1000 Newton, that is the weight of this is 1000 Newton, 1000 Newton roller over 15 centimeter obstruction as shown in the figure. So there is an obstruction and this is a wheel. We wish to have a force so that we can push it over this. Now let us make the free body diagram of it. The radius of wheel is given 630 centimeter and this obstruction is 15 centimeter. If we make the free body diagram, the one force is acting here, weight will be acting downward like this, reaction from here is going to act like this, and interestingly when this is going to move on this R1 is going to be 0 at the time it is going to lose the support contact from here. That means the contact will be only here, so it will lose contact from here, so R1 is going to be 0. That is required to be understood. So R1 will become 0. Now it is the equilibrium under three forces. One is this, and third one is this. Now we should also understand one more important concept here. If there is equilibrium under three forces, 1, 2 and 3, then equilibrium is possible if two of them are passing through a point, like P is coming from here and weight is acting here. So if two are acting at a point, then it is necessary that third should also pass through this point, otherwise equilibrium will not be possible. So equilibrium under three force is there. If two are passing from one point, then third must pass through the same point. This will basically give us the direction that reaction acting here should pass through the center. That is, we have shown it here. Now we can use this triangle to determine the value of theta. So value of theta can be determined by this upon this, because here to here it is 30 and here to here it is 15. So this is 30 minus 15. So this upon this, that is sin theta, is 30 minus 15 by 30 is 1 by 2, that is 30 degree. So we'll have now only three forces acting. One is P, one is W, one is R. If we'll transfer the angles, this is going to be this kind of situation. We can use equation of equilibrium, or simpler way we can use Lami's theorem, because it is concurrent force system under three forces of application. So using the Lami's theorem, we can pick up the value of force, corresponding angles. So P upon sine this, W upon sine this, R2 upon sine this, we can use it to determine the value of R2 and P. It is required to calculate the value of P, and we can directly get it from here by using Lami's theorem here. So important to understand again that if there is equilibrium under three forces and two of them are collinear or passing or concurrent, then the third should not collinear. If two of them are concurrent, then third must also pass through the same common point. So if one is passing from here, one is passing through here, then third must pass through here. So this is an important kind of concept what we should always implement if there is equilibrium of forces under three forces. Let us take another problem. There is a cylinder or spherical object. It is against two inclined plane. One is at 45 degree, another one is at 60 degree. Now it is again going to become equilibrium problem. Let us understand how it will come into the picture. So weight is acting here. One of the reaction will be coming from here and one of the reaction will be coming from here, contact point. Now we have to understand how reaction come on if it is there, a sphere is there on an inclined plane. Reaction will be from contact point towards the center. If this angle is theta, then this angle is theta. This is 90 minus theta. This will become theta. That means this angle will become theta. That means whatsoever was the angle of inclination with the horizontal, same will be angle of reaction from the vertical. So this concept can be used simply to determine what is the direction of reactions. So reaction, because of this at let us say R2, and reaction because of this, let us say R1. So R2 will make an angle of 45 with the vertical which the plane is making from the horizontal, and R1 will make angle of 60 with the vertical what plane is making with the horizontal. So ultimately the free body diagram I have shown it here. R1 is like this, R2 is like this, and W is like this. So it is becoming again 3/4 concurrent system problem. We can simply use Lami's theorem to determine the value of R1 and R2. It's very simple. We can say R1 upon this angle is equal to R2 upon this angle is equal to W upon this angle. So these all angles are known to us. We can use Lami's theorem directly to solve this question to determine R2 and R1. R2 value is going to be 894.4 and R1 value is going to be 729.9 newtons.